All right, hello. So far, when we've talked about inequalities, we've mainly focused on the representation of the data, of the outcome, of something perhaps like such as n is greater than 3 via a number line. For instance, if I put 3 here, the inequality n is greater equal to, or is greater than 3 is represented by an open circle there, and a ray shooting out to the right towards the positive numbers, of which, for instance, 4 exists, that are each greater than 3. Now, sometimes we want to be able to represent this data in a way that kind of takes up a little less space. For instance, look at all the space that this guy's taking up. If I shrunk it down, well, let's just see what happens. You imagine as we keep going further and further down, to like the same size as our expression there. Well, at this point, I can't even read what that says. So I'm going to blow this back up. Shebang. And now I'm going to think about, is there another way that I could represent essentially this line here, as well as this circle here? And, well, the way that we've canonically in mathematics denoted such a graph is with something called interval notation. Now, interval notation works like this. On the ends of your interval, you're either going to have one of the 4 choices that I've written out here. Notice the curviness of the parentheses, what I've highlighted in red, and note the rigidness of the square brackets that I'm highlighting in blue. And notice how we have kind of a pairing of either 2 parentheses on the left-hand side, 2 brackets, or 1 of either. Now, when it came to our graph, we had 2 different options as well. An open circle or a closed circle or filled in circle. I will tell you that the closing circle is represented by the brackets, and the open circle is like the parentheses. And so if we were to think about our interval here, we are not including 3 in this inequality here. And so if we were to use interval notation, if we involve the 3 here, because when you think about this ray here, 2 big things that define a ray are where does it start and where does it end, or where are the 2 endpoints of this ray? Well, one of them is at -3 or at +3. The other one is at, well, infinity, because it just keeps going on and on and on. You keep getting larger and larger, and it just approaches this value infinity. Notice that you never really touch infinity as you keep going along, because, well, you just can keep going, and that's kind of what infinity is. You never reach it. And so on the right-hand side of a graph, we have the number infinity. And then, of course, we have all the stuff that's between 3 and infinity. And I'm just going to list off 3 and infinity in a little list here, a little list where we have the first entry is the left side, the second entry is the right side. And I'm going to close these off with parentheses because here we never touch infinity. So there's going to be like an open circle at infinity. If you think about it graphically, maybe it looks like if I were to put infinity here, you'd have like an open circle between these two. Now this idea might be a little bit more confusing, so I don't necessarily encourage you to think about it in terms of this. But here, imagine we're using this, where like this is as far as you can go, which of course like you can still technically go further, quote unquote. But the idea is you kind of approach this never reachable spot. You just keep getting closer and closer and closer and closer and closer as you make your way ever so more along the way, and eventually you will reach that infinity. We never include it, but we approach it. Now on the left-hand side, we kind of by definition say anything that's greater than 3, we should work this way, we get ever closer to 3, but we never quite hit it. It's not included. And so we have interval notation is simply a way to describe the left-hand side of our data the right-hand side of our data, and then what happens as we approach each side. Now, some other little things to consider here are, for instance, what if this was less than 3? Well, then our graph would flip, and we would go this way. Well, 3 is now on the right-hand side, so the right side of our data. And what's over here? Well, it's not infinity, it's negative infinity. As we keep going left and left and left, eventually we're going to get closer and closer to the negative extreme, which is kind of like an idea again. We never quite hit it, but here we would say that we're on the left-hand side of our data, our little ray. We have negative infinity, never touch it, so we have an open parentheses. And then we go to 3 and close it off, because that's where we end up on the right-hand side of our graph. We are now at 3. Now, what if we were at less than or equal to 3? Well, then we would fill in the circle, and you might notice that we include 3 now. And so what we're dealing with is the brackets. We would throw a bracket on this side. And similarly, if it was greater than or equal to 3, we would start with a bracket. One other special note I will make here is that infinity, we can never reach it, so it's always going to be parentheses, the curvy one. Never will it be a bracket. However, of course, I did offer as a suggestion that you might be able to use 2 brackets. So when is this the case? Well, we use the brackets, a pair of brackets, when we're doing with number line. Maybe that's 0. Maybe this is -3. Maybe this is +4. Well, with our and inequalities, maybe we have n is greater than or equal to -3, and n is less than or equal to 4. Well, then we have circle filled in at -3, circle filled in at +4, and then we connect in between. Well, if you think about our solutions here, we have a line segment that starts at exactly -3, not above it, not beyond it, not close to it, exactly at 3, or -3, and we go to +4. That's the right-hand side, +4. And so we read this from left to right, like we would read our graph from left to right, -3 to 4. And yeah.